In this short video we will explain the diagnosis and repair of the Capacitive Soil Moisture Sensor version 1.2. As part of our Green Finger project we chose to use this very popular module to help monitor the correct soil humidity. Unfortunately we hit a snag and found very little information as to why ours did not behave in the same way as all the other examples out there. Here's a look at what was wrong. First of all, the very simple Arduino code opens a connection to the serial port, reads a value from the analog A0, prints that value to the serial port, delays for 100 milliseconds, and then returns to the beginning of the loop. Now let's see what happens when we introduce our sensor to something very wet, such as my glass of blackcurrant juice. Well, as you can see, something is definitely happening. The problem is it's happening very, very slowly. Much slower, in fact, than any of the examples we've seen on the internet so far. After checking and rechecking the connections to the Arduino, checking the minimalist sketch that we have here, can't find anything wrong. Is it possible that my submerging this sensor in varnish several times, as suggested by some of the tutorials, in order to seal up the edges of the circuit board, is it possible that that has caused a problem on this particular sensor? Perhaps this sensor was faulty when it arrived. I don't remember testing it. It's been sat on the shelf for probably over 6 months. As you can see, when the sensor is removed from the liquid, it begins to crawl up very, very slowly indeed. Since this has a very thick coating of varnish on it and it's difficult to see the components on the board even, I think the best idea will be to order another one. And because I'd like to get this done soon, I'm going to order one from an English seller. So we will come back to this when the items turned up. And turn up it did about 3 days later, which is not too bad. Unfortunately, there are a couple of things wrong with it. Firstly, looking close at the board, C1 is absent. Now, looking very closely at the board, we can see that it was soldered there at some stage, but somehow became detached between the factory and my workbench. However, the sensor arrived in a jiffy bag and it was also sealed in an anti-static bag as well, and the capacitor was not in there, which would indicate that the capacitor became detached before it left the factory. See what is shown on the top right corner of this diagram. It's a smoothing capacitor on the 3-volt output of the voltage regulator. I happen to have some of these left over from previous projects, so I will be able to replace this one. And so moving on to the second problem with this sensor, it doesn't work. It is displaying exactly the same problems as the one we were using before. In an effort to keep this video as brief as possible, we will go straight to what we found to be the problem. When using a digital multimeter to measure the voltage between the cathode of D1 and ground, the Arduino began giving us more realistic results, indicating that the multimeter was somehow loading the output of the sensor. This in turn led us to believe that there could be something wrong with this 1 mega ohm resistor, which is marked as R1 on the board, and closer inspection revealed that the top end of this resistor on the diagram, or the ground end, is in fact disconnected. So, a few things to consider. 2 sensors which are similar but not identical, purchased 6 months to a year apart, one from a Chinese seller, the other from a UK seller, yet both have the same defect. Neither can function as described without modification. How many more thousands of these defective devices are there waiting to be sold? How many people are going to buy these devices and not have the technical know-how to get them to work? How many sellers are aware that they are selling items which are not fit for purpose? Now I know what you're thinking. I haven't shown you the fix yet. Well, the fix is simple, and here it is. Take a 1 mega ohm resistor and place it between the signal pin and ground. Then marvel at the results. I think it's clear to see very much more responsive, repeatable, meaningful results. If you found this video useful, informative or interesting, please like, subscribe and feel free to comment below. And as always, thanks for watching.